Hello, hello. As you're joining us for our hydroponics webinar today, we would love to know where you're joining us from, what your role is to get a better idea of who's here with us today. So if you can drop into the chat your role within your school or district, what city or state you're coming from, we'd love to get a great idea of who's with us today. We'll give just a couple minutes for everybody to jump in and join us, and then we'll get started in just a few. In just a couple minutes, we'll get started with our hydroponics webinar, talk about growing 21st century skills and problem solvers in K-12 using hydroponics. If you're just joining us, please drop your role at your school or district in the chat. Tell us where you're joining us from. We'd love to hear a little bit about who's with us today. And see, I know we have people from all over the country joining today, so we'd love to know. All right. Well, welcome in. We're going to talk about growing 21st century skills with hydroponics today. And whether you're joining us from a district administrator role as a teacher in the classroom, we're really excited to share some of these ideas with you today. We want all of our participants today to be leaving with new ideas about how to use hydroponics, hopefully to demystify some of the aspects of hydroponics that may have prevented you from using them before. So to start off, I want us to think about what you had for dinner last night. Every element, every plant or vegetable that was a part of your dinner, I want you to think about what all those pieces came together to make and how far they came to get to you. So whether you had a salad or a curry with vegetables, there's a lot of different things that you have traveled to get to your plate from production through processing. Even if you're dining at a restaurant, by the time it gets to you, it has traveled a number of food miles. So when we think about how our different vegetables and fruits get to our plates, these are rough estimates of what the distance in food miles each of them has traveled to get to you, assuming you are in the United States. So as many as 5,000 miles just to get to your plate. And when we think about hydroponics, the joy and the excitement of hydroponics is growing your own vegetables, leafy greens to reduce your food miles to food feet or food inches. So when we are excited about that for ourselves and for our students, it helps ground the importance of hydroponics to all of the participants in that classroom or school garden that we'll be creating. By way of introduction, my name is Hope Thompson. I'm the Program Operations Manager at NextWave STEM. I'm a former science teacher in Baltimore and Chicago Public Schools. I also had roles in instruction and curriculum for robotics for pre-K through third grade students. And I'm really excited about the way that hydroponics in particular, all of our emerging techs, but certainly hydroponics is applicable for students all the way from pre-K up to 12th grade and has different ways of relating to their learning goals along that spectrum. So today we're going to think about what is hydroponics. When we talk about that phrase, what are we describing? Some benefits of bringing hydroponics into a classroom, and we're going to talk about some barriers and address some places that we might be able to provide more support to help teachers and schools and districts feel more comfortable starting a hydroponic system in their schools, and some tips and tricks for making sure that they're successful, not just for one semester, not just for one unit, but long term, year after year, how you can have this sustainable approach to plant knowledge and plant learning in your school long term. So what is hydroponics? It's a technique of growing plants using a water-based nutrient solution rather than soil. So there's no soil involved, especially when we're talking about one specific kind of hydroponics, which is deep water culture. There are different variations, including aeroponics and drip systems. The most common kind of hydroponics that you're going to see in schools and classrooms is that deep water culture. It is the simplest, easiest to maintain, and is usually the best fit for educational purposes. So why do we have hydroponics? What are some of the pros of that system? For one, it's more water efficient. We're reusing and recycling the same water that's a very controlled amount. We also see higher yields because it's a more controlled space. We're able to control for environmental factors, leading to higher yields and faster growth. We also don't have to worry about natural pests the way that we would in a traditional soil-based garden, and we can grow them year round. Again, that controlled environment allows us to grow plants out of season. And there are so many STEM connections to what students might be interested in or learning elsewhere. Not only the plant science on display here, but also the connection of thinking creatively around farming problems and having this soil-free solution that can be applicable in a lot of different situations. So when we're comparing hydroponics to a soil garden, you're going to see a lot of visible physical differences. For one, we are able to stack a hydroponic garden, which is again contributing to that higher yield, and it's going to take up a lot less space than a sprawling soil garden. Again, a lot less of the variability of having to deal with environmental factors, outside pests, and having that controlled environment indoors, allowing us to grow all sorts of different plants all year round, requiring a lot less space than a soil garden and a lot less seasonability than even an outdoor garden at a school can provide. So I want to stop here and think about everyone who's joining us here today who has an interest in hydroponics, but may have encountered some barriers to bringing it to their school, classroom, or district. So if you could join us in the chat to share some barriers that you may have found to bringing hydroponics in, whether that's just understanding hydroponics and how it could relate, or the physical space and how it will be a part of your school. Please share in the chat some barriers that you or others may find to bringing hydroponics into schools. Yeah, the cost and the time definitely part of it. Whether or not you're going to have the time to maintain it, what sort of investment that you're making, and buy-in. Yeah, can we get enough people at our school, whether that's teachers or whether that's our students, to really feel like this is something that belongs to them and that they will be a part of maintaining year after year. Again, we want it to be this sustainable solution. So it's not just your plant unit that you do for a month. It's not just a semester when it was new. It's something that we're going to always return to and be a part of our school or our district's science offerings. Yeah, the physical space is something that comes up a lot. Where are we going to put a hydroponic system? What kind of size are we talking about? Whether we're stacking, how do we make sure that this is something that isn't a huge barrier to using or making the most of our space? How does it fit with other programming? Yeah, definitely. How is it relating to other disciplines outside of science? Is it something that's going to just be insular? Yeah, how are we keeping it clean? That's a big part of it. Okay, great. So you all are hitting a lot of the sort of barriers that we hear often, which includes maintenance and material management, long-term sustainability. How are we going to deal with this year after year? Understanding what hydroponics is and the appeal of hydroponics, how it's connecting to what students are learning elsewhere, etc. So we're going to address all of these. Hopefully by the end of our time together, you're going to feel a little bit more comfortable with addressing whether or not these barriers will still exist for your school or district and how you can navigate them. And let's talk about benefits. So everybody here has likely already identified some benefits of bringing hydroponics into a classroom. It's certainly a really exciting way to reinvigorate existing plant science units. But I would love to also hear about some benefits of why you think this would be a valuable thing to bring into your schools or districts. If you can drop some ideas in the chat, I'd love to hear from you all on that as well. Yes, definitely the hands-on learning aspect. There's really nothing like holding or touching a plant that you and your classmates have been growing over the past few weeks and getting to see this realization of the work and the learning that you've been doing. Having access to fresh food, absolutely. Knowing that you've been following this project, whether it's a head of lettuce, um, from the very beginning through harvesting. Yeah, getting to sample is a great aspect as well. We really find a lot of the time our instructors especially love that time where students are getting to sample, maybe even having foods that they've never had before, learning new herbs, and getting to really taste what they've been working on too. Yeah, so we're going to talk through some of the top 10 benefits of the hydroponic systems in classrooms. And that's going to include these long-term goals. So having students think long-term about something that won't be there tomorrow, but will be in a few weeks. Having some practice with failure and iteration. There's a little trial and error that's built in anytime you're talking about gardening or growing plants. Getting to have some practice with variables, designing experiments, and documenting, observing, and recording the results of those variables. Getting that analog, off the screen, hands-on experience, also really valuable to our students, as well as that environmental connectedness, having a real example of the plants that they've been learning about in their classrooms, especially if they don't have a lot of access to that outside. If you're in a really urban area or you're doing a project on native plants, then you can have those examples in your classroom and help students feel more connected to those in a very real way, as opposed to something that might be a little bit more theoretical. It's also bringing that health awareness of foods and where they come from. It's very variable in terms of what it can connect to, what we scaffold throughout, whether that goes from the simplest from pre-K all the way up to more complex plant science in 9 through 12. There is an undeniable joy and ownership of having grown something yourself and having it belong to your school and to your classroom, not just as an achievement, but as a process. It's something that is reusable and sustainable year after year. I know that's come up in the chat. And cross-curricular. There are a myriad different ways that these hydroponic ideas can connect outside just of biology or plant science, but into other disciplines as well. So when we think about the long-term goals portion of the benefits of hydroponics, we're talking about planning with students the time and commitment of a multi-week project, knowing from the start that this is something that will take a number of weeks before we see results, and we'll need to be organized about our approach, helping to practice with delayed gratification, especially with our younger learners. This is not going to be a whole head of lettuce tomorrow, but day by day, we're going to get to see it and try it out at the end. And also backwards planning, thinking about if we want to have a salad at the end of our unit, why do we need to plant today, even though we're thinking 5 weeks, 7 weeks in advance, helping students practice with that backwards planning from a goal to build smaller steps along the way. So this is just an example of the very beginning of a hydroponics unit and the very end. One of the most fun days of the year is when our students get to put together some of the lettuce and different leafy greens that they have grown and make a little salad. It's really exciting for the educators. It's really fun for the students, especially if they're getting to see different plants and know that they grew it themselves. We also know that failure, trial and error, and iteration are part of the process. That's part of anything that we introduce to students along the engineering design process, that we want them to be trying something, noticing that it doesn't work exactly as planned, and then appropriately responding and adapting their next steps. So students have this opportunity to change their different approaches and see different outcomes, whether that means what sort of water we use, where we put um, the hydroponics in our classroom, how often we change out the water, what kind of plants we grow. There's all these different iterations of variables that students can control and get to see the results. So getting to create and test these experiments that they have designed to hit on some of those NGSS skills as well. Students are getting a way to do that in a new way in their classroom. Again, very hands-on and getting to see the results in real time. So here's just one example of students allowing a little bit of air into their germination bag to see the difference between no air and some air. Done alongside a hydroponics system, it provides more practice with the designing and testing different experiments. And again, increasingly for our students, having time where they are off of screens, but still getting meaningful STEM experiences are more and more valuable. So they're getting really hands-on tactile experiences, which increase engagement for all learners and help make sure that everybody in the classroom, the school who is participating in the hydroponic system, get to see and feel the fruits of their labor, quite literally. This is just an example of just how large some of these plants can grow in a hydroponic system. It is not a small sort of indoor version of the lettuce you'd be growing in your soil garden outside. These are really robust, significant plants. So students have more than enough to go around. Everybody can sample a little bit of the plants that they've grown, and they get to see this real example of their work. We have that environmental connectedness, getting to really interact with plant life. Again, like I said, if you're in a really urban area or you have a sprawling school campus, you're not able to get out into plant life terribly often with your students. This is a great way to bring it into your classroom, to make connections to wild and domesticated plants, especially if you are working on native plants in your area. You can practice identifying with students. Our middle school and high school students getting to learn a little bit more about identifying different types of plants. This is a great way to give them more examples of different plants that they might not otherwise find in their immediate area. And having a higher health awareness of their food, where their food is coming from, thinking more critically about chemicals, pesticides, and contaminants that might usually be a part of foods that are grown far from them, getting to have that conversation with students about your food miles, reducing those food miles in this case into the classroom, and getting this reward of micro farming. Not only is it healthier, more controlled, we know exactly what went into it, we do often see that these have great rewards in taste as well. These are really high quality plants that students are getting. Also, thinking about food deserts in areas where fresh produce is less available. This is a great way not only to start that conversation with the student, but also address how we can bring more of hydroponic systems and utilize that technology to these areas to introduce more fresh produce into areas that otherwise do not have it. And when we think about different levels of scaffolding, this is a topic that can relate to a lot of different grade levels. With K to 2, this is a wonderful way to breathe new life into existing plant units. Your first and second grade students who are already doing parts of a plant, thinking about what plants need, they have a chance to set up a hydroponic system and observe and design those experiments to see those basics. Do plants get the nutrients they need, the sunlight and the water that they need? What kind of different plants do we see and the different parts that we've learned about? In third through fifth grade, we can start to increase the complexity of those experiments, different types of crops, different circumstances of growth, and controlling those variables a little bit more. At 6 to 8, we can again deepen that complexity and think about different nutrients in different volumes, modifying and measuring the pH of the water that they are growing in their deep water culture. And at 9 to 12, we can also start to push towards some of those career connections. What does harvest look like? How can we think about packaging and marketing some of these crops that we're creating? So for example, growing wheatgrass, using a juicer to create a health drink with that wheatgrass, designing a business around the health drink and bringing that to market. So we can push even further from growth into agribusiness. And again, we have the simple side of just learning the parts of the plant, all the way up to different plant cells, different plant tissues. So regardless of the depth of learning that students are addressing with this hydroponic system, it can relate to the plant science and biology units and learning goals that they already have. And there's an undeniable joy and ownership of harvesting and eating your first crop. Like I've said, it's just a fun day, that day that you finally have that salad. It gives students control and ownership over this project and is a great way to increase their buy-in, not only for this unit, this classroom, this subject, but also their experience at school in general. And this is something that is reusable year after year. So the hydroponic system has a long shelf life. Once you have that up and running, you can replenish the planting sponges, the nutrients and plant food, the seeds that you're using. You don't necessarily have to start fresh every year. These are very economical options, just replenish here and there, but the same system can be used year after year after year. And we see a lot of cross-curricular connections. So for example, the entrepreneurship, the wheatgrass health drink business that we just discussed, connecting to cooking, of course, biology and plant science, agribusiness, thinking about these large scale, not just the two systems we have in our classroom, but wall-to-wall warehouses full of hydroponic systems, what the agribusiness would look like on an operation that large. Thinking mathematically about pH parts in the water that students are manipulating, plant food and nutrients, being really particular about measurement with that, and the computer science and robotics aspect as well. We do see examples of automated and autonomous hydroponic systems in the real world, so making connections on how we can relate to that. It's also a great way to think about real problem solving based on existing problems, including food availability and vegetable availability in food deserts, thinking about space travel and how we can sustainably continue in that direction, and finding those literary and literacy connections through supportive texts. So where do we start? If you're excited about hydroponics, you see how it fits in to your school, your classroom, your district. Where does one begin? The first thing you'll need to do is get a kit. Now, the kits can range in size, but are most generally about 1 foot by 2 feet large, stand about 2.5 feet tall. And they come with a base and a grow light, seeds, planting cups, and sponges that act to hold onto the roots, and then the nutrients that you're going to add to the water so that the plants can have everything they need even without the soil. And then you want to think about what plants are going to grow best in this unit. We suggest starting with leafy greens like lettuce. They grow very quickly and consistently, and they grow very large. They're just visually very rewarding to see the progress, especially when you have this really abundant growing over of leafy greens by the end of their growth period. Wheatgrass also is another good choice that grows quickly and visibly. Students can get really excited about it. To prepare the tank, you would fill it with water and food. Again, that liquid plant food, which has the nutrients. Pre-moisten the sponges by soaking them for a few minutes. And then place 3 to 4 seeds in each of those sponges. There's a dome to protect the seeds over each one of the plant cups as well. Then begins the data collection. So this might be something your students are taking part in as well. You can label them by the class that uses them. Maybe you're sharing it across a few classes and you want this row to be your third graders and this row to be your fourth graders. Maybe every student is responsible for one plant and the observation and recording of that plant's growth. And you can begin to test different variables. We know that the hydroponics have enough light with the grow light. Do we see a difference when we move it closer to the window versus in the corner by our coats and backpacks? Do we find a difference when we grow with water from the water fountain or a gallon of distilled water from the grocery store? What about when we change the nutrients in the plant food that we add? If we have more of plant food A versus plant food B, do we see a change? It's an example for students to practice seeing quantitative and qualitative data, developing those scientific observation skills as well. For long-term maintenance, it really can be as few as a couple of hours every other week just to check in on how your hydroponic system is looking. With our older students, they can play a role in this maintenance. It can be a classroom job. It does not need to be a lot of buy-in for one teacher in particular in your school. It can be something that is shared and not too much of a burden. So we really just want to be testing the pH of the water to make sure that it is an appropriate level to support growth, adding nutrients and flushing out the water every few days or so, keeping an eye on the roots that they're not getting any rot or too tangled. And then when we think about harvest, we can, pull plants out from the sponge from the root, but we also have this cut and come again method option where we can cut off a leaf, make some observations, or make a salad depending on the goals of your classroom, and that will continue to grow. We can think about what is happening with that plant afterwards. Think about juicing those wheatgrass leaves as well. Are we thinking past just the harvesting of this plant? Maybe we're pursuing cooking and simple recipes. And we can also even think about seed collection. So it can be a really sustainable solution where we're harvesting seeds from the plants that we've grown so far and reducing the need to purchase additional seeds year after year. So we also have some tips and tricks, having successfully done a hydroponic system in a lot of different schools, different districts. There are a few things that we know can make them more successful long term. You want to start, especially with fast growing plants, to sort of kick off your system and your students buy in those leafy greens like lettuce and wheatgrass. We also recommend creating a maintenance schedule. We want this to be sustainable, more than just one teacher at your school being in ownership of it, more than just this is what we got for the plant unit this year. Maybe we'll use it next year, we're not sure. The more that you invest in creating a maintenance schedule early on, especially if you're going to include students, the more self-sufficient that the system can become. And having different student groups and responsibilities, even with their K through 2 students, is a great way to make sure we have that student buy-in and that the lift on classroom teachers is not so high that it becomes a barrier to introducing the system. So that can be someone is in charge of changing out the water, someone is in charge of making sure it is plugged in, different responsibilities that students may have, again, depending on their grade level and the appropriateness of those responsibilities for their different ages. Make it part of your classroom routine or your school routine so that it is a regular part of the classroom more than just during science or during this unit. It is just like having a classroom pet or maintaining the cleanliness and organization of your classroom library. It is part of the routine of your school and your class. And we really recommend making the hydroponic system visible but out of the way. We are not talking about an enormous system that is a huge barrier to making the most of your classroom. And it's not a wall of hydroponic plants growing. It is a 1 by 2 by 2.5 system. Maybe you have one or two of them in the corner here, or alongside a bookshelf there. Because it has the grow lights, you do not need to worry about it being near the window, and you are constantly replacing and replenishing that water, so you don't need to worry about proximity. So if you can find even just a couple feet of space in your classroom, you can find a place for it to be part of the classroom, but not in the way of other activities. And keeping an eye out for pruning the plants that you've grown, flushing out the water so that you can maintain the health of your system long term. So when we think about what to grow, I'd love to know if you have any particular interests in growing, maybe relative to your area. If you have a unit that you feel would really benefit from different types of plants, especially in our 9 through 12 science classes where we get to more in the complexities of different plant species. So any ideas that you may have for what to grow that would particularly interest you and your students, please drop them in the chat. We do have a little guide for what grows best. So I'll say again, those leafy greens, they're fast, they're highly successful, they are ready to harvest in less than a month. Herbs, very similar and are a great way to expose students to new plants, new flavors, new ideas. Cucumbers also grow quite rapidly. They do have long vines to manage, but can be a great way to see something very meaningful and very quickly grow. Students are familiar with cucumbers and excited to see that there is a whole vegetable in their classroom where there wasn't before. Those plants in yellow are sort of a maybe. It depends on whether you have experience with the hydroponics before and the needs of your classroom. They're going to take a little bit longer to grow. They might have a little bit more of physical needs of allowing for their space. And then the orange are ones that are not the most appropriate for a hydroponic system, whether they usually need to have more of a tree trunk before they're ready to flower, or trellis, or they're just more difficult to grow. Or in the case of potatoes, are actually root-based, so we don't want to be thinking too much about something having more customization needs to grow successfully in a hydroponic system. You also want to keep an eye out for the success of your root systems, making sure that they are healthy, they're not getting tangled or rotted, which may happen as a result of nutrient imbalance or algae growth in your system. Again, pruning and flushing, creating maintenance schedules with the help of your students will help prevent some of those. You also want to keep an eye out for salt buildup or any clogs in the flow of your system. It is like any faucet or fountain is going to have the flow of water through. You want to make sure that the water you're using is clean and that you're keeping an eye on those systems. So if you are interested in bringing hydroponics to your school, you see the connection to you and your classrooms, you and your students. NextWave STEM does have offerings to help bring hydroponics learning experiences to your school. It will take some of the guesswork of how to relate these experiences to your students out of your planning. So from K through 12, we have curated, engaging, creative curriculum on hydroponics. That includes 15 lessons, activities for our K through 2 students. That includes a little workbook of their documentation, of their observation throughout the unit, as well as any supportive resources. That's going to mean texts that students are doing as read alouds or pH probes, or additional materials to run experiments alongside the hydroponic system, so that you have this sustainable system year after year and don't have to do all of the planning and work of figuring out how you're going to relate these learning experiences into your science classrooms. That also includes professional development and on-demand support for those programs. So I do want us to allow some time for any questions that you might have about the hydroponic systems, either that NextWave STEM provides or that you're interested in about introducing to your schools and classrooms. So if you have any questions, please drop them in the chat and we will address them now. Yes, we will be sharing the webinar recording on Monday. So you will have access to all this information. The tips and tricks will be available to you. Well, no questions in the chat, I hope means that we addressed all the potential barriers that we heard at the beginning of our time together. If you're still feeling like there are some last thoughts that are just keeping you from bringing hydroponics into your classroom and you want to discuss more, I hope you'll reach out to NextWave STEM. We are happy to provide a little bit more context on our offerings, our recommendations when it comes to including hydroponics. And I'm happy to provide more information as well. My email address is hope@nextwavestem.com. Quite easy to get a hold of. If you shoot me an email, I'll be happy to set up a time to chat with you or to provide a little bit more information on what hydroponics can look like, specific and custom to your school or classroom. All right, thank you all so much. We hope to hear from you. Happy growing.